Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be raising a complex number to the 17th power. I'll be presenting two methods, even though one of the methods will be incomplete. Alright, so let's start with the first method. For my first method, I want to go ahead and separate these. Since I have a over b to the 17th power, I guess I could call them z and w as well because they're complex numbers. We can basically write this as z to the power 17 divided by w to the power 17, right? So by that formula or identity, I can write this as the quotient of two 17th powers. Guess what? You're going to use the binomial theorem, right? With 18 terms. Don't do this. Use something else. Obviously, there's something else that you can use, but think about it, what it could be. I'll be proceeding with the second method. Okay, cool. Let's leave it like that and continue with the second method. So for my second method, I'm going to focus on what's inside, right? That makes sense, because if I can simplify this, raising it to the 17th power should be no big deal. Well, at least it's going to be easier than raising a quotient of complex numbers to the 17th power, hopefully. So let's go ahead and multiply the top and the bottom by 1 minus I, which is the conjugate. And then we're going to distribute. There's no easier way to do it, right? Square root of 3 minus square root of 3i plus I minus I squared. That's going to give me a plus 1. All of that is divided by 1 plus 1, which is 2. Remember, that's the sum of two squares. Well, we get square root of 3 plus 1 in the real part, and the imaginary part is 1 minus root 3. That's going to be multiplied by I, and all of that is divided by 2, which means the real parts actually are divided by, real and imaginary parts are both divided by 2. So we can kind of separate these two things and write it as root 3 plus 1 over 2 plus 1 minus root 3 over 2 times I. And you can clearly see the real part and the imaginary part, right? Cool. Now let's go ahead and take a look at a couple things. This is a number that I need to raise to the 17th power. So it better be a special number, right? So one of the things that we're going to check is the argument. Because if the argument is a special angle, then raising it to the 17th power should be a piece of cake. If not, then we have to use the arctangent or tan inverse, and depending on the what is that called? Not conjugate. The right word is quadrant. Yes. Depending on the quadrant, it could be the arctan or pi minus arctan, so on and so forth. Different variations, a lot of complications, right? So here's what we're going to do. We're going to look at tangent theta. So whenever you have a complex number like z equals a plus bi, you should definitely know that if the argument of z is theta, then tangent theta can be defined as b over a, which is this divided by that, right? Easy. The thing is, to find the cosine and sine, you need the modulus, but for tangent you don't, because it cancels out. So let's go ahead and find the tangent theta for this number. What is the tangent, right? Okay, so we can go ahead and do it as b over a, so it's going to be 1 minus root 3 over 2 divided by root 3 plus 1, but I'm going to write it as 1 plus root 3 over 2. The 2's cancel out, leaving us with something like this. And then this can still be simplified. Remember the conjugates? They're very helpful, right? Let's go ahead and multiply by those. We're going to have this something squared in the numerator. So tangent theta is going to be 1 minus root 3 squared. And at the bottom, we're going to have sum of two squares again, 1 plus 3, which is 4. Let's simplify the numerator. 1 plus 3 minus 2 root 3 divided by 4. This is a 4. And if you divide everything by 2, right? Then you're going to get 2 minus root 3 divided by 2, right? Okay, if you didn't make a mistake, we should have a different answer. Let me double check. Yes, this should be 1 plus 3. It should be 1 plus 3 minus 2 root 3. Okay, so it looks like 4 divided by 2 is, 4 divided by 4 is, okay, never mind. I got the idea. It's not complex numbers. Okay, I was thinking about sum of two squares. It's supposed to be difference of two squares. There you go. Okay, Now, tangent theta from here is just going to be 1 minus root 3 squared, which I already have as 3 plus 1 minus 2 root 3, divided by 1 minus 3, which is negative 2. Okay, here we go. Now, this will be divided by 4 minus 2 root 3 divided by negative 2. Now, I can kind of negate the top and write it as 2 root 3 minus 4, and all of that is divided by positive 2. And that's going to give me the tangent theta as root 3 minus 2. Great. If you do know a little bit about tangent, first of all, this is a negative tangent, which tells you that you're either in the second quadrant or the fourth quadrant. And how can you tell? By looking at sine and cosine, or A and B. Notice that A is positive, B is negative, right? So that means we are, and remember A is cosine, right? It's going to give you the cosine basically. So we are in the fourth quadrant. So that's going to be an angle between 270 degrees and 360 degrees, or 3 pi over 2 and 2 pi, or negative pi over 2 and 0. Makes sense? Depending on how you express it. But we are in the fourth quadrant. Awesome. Now let's go ahead and see how we can handle this, right? So my goal is to take this number and write it as r e to the I theta. In other words, I want to find the modulus and the argument. And then, of course, when I raise this to the 17th power on both sides, what's going to happen? R will be raised to the 17th power, and the argument is just going to be multiplied by 17. Easy. Once I find the argument, you can just multiply by 17. And once you find R, you can raise it to the 17th power. Easy. So the question is then, what is R? The modulus, right? Easy. We are trying to find the absolute value of this, and we have a really nice rule that you can separate this into two absolute values and divide, separately find them. This is 2, this is root 2, so the absolute value is root 2, without getting into any complications. Awesome. Now, let's go back to theta. Remember what I said about theta? Tangent theta is negative. We're in the fourth quadrant. If theta was in the first quadrant, then tangent theta would be 2 minus root 3. Does that look familiar? If it doesn't, I'll show you something. Okay, here we go. Ready? Tangent 45 degrees minus 30 degrees. Take a look. Tangent 45 is 1. Tangent 30 is 1 over root 3. And 1 plus their product is 1 over root 3. This becomes root 3 minus 1 over root 3 plus 1. Does that look familiar? Yes. And now, after doing the conjugacy, right, the conjugate thingy, you're going to get tangent 15 degrees as 2 minus root 3. Wow, that's what it is. Well, if you memorized it like me, then you should immediately know. But if you didn't, how would you find it, right? That would be a really good question. Of course, there is another way to approach it, but I just want to go this route. So tangent 15 is this, but our angle is in the fourth quadrant, so we kind of have to convert it. We can do 360 minus 15 degrees, which is 345 degrees, or just negative 15 degrees, which is obviously a lot easier. And with the principal argument, obviously, we want it to be between negative pi and pi, right? So here's what we're going to do. Remember, we're supposed to raise this to the 17th power and multiply the argument by 17. But we already know R, don't we? R is root 2. R is root 2, and theta is negative 15 degrees. Wait a minute. How do you raise negative 15 degrees? Or I can write it as negative pi over 12, right? How do you raise it to the 17th power? Easy. You're just going to multiply by 17, right? So we get the following. Root 3 plus I over 1 plus I to the 17th power is root 2 to the 17th power, which is R to the 17th power. And then times E times 7 pi over 12. Oh, by the way, how did I get 7 pi? Where did I get that from? Okay, let me explain. I skipped that part. Sorry about that. Forget it. Now, here's what we do. So we multiply this by 7, right? We have negative 15 degrees. Let's multiply negative 15 degrees by 7. That actually gives us negative 255 degrees. If you add 360 to it, you're going to get 105 degrees, which is 7 pi over 12. Make sense? That's how I got it. I just wrote it there. I don't know what I was thinking. E to the power I times 7 pi over 12. So that is our argument multiplied by 17. in the simplest form, of course, right? So that should be the answer. But what is this? This we can kind of write as root 2 to the 16th power, because I want to separate one of these. 16 is even, remember. And then this can be written as cosine of 7 pi over 12 plus I times sine 7 pi over 12. And from here we get 2 to the 8th power, which is 256, multiplied by root 2. And inside, multiply this, write this as root 2 minus root 6 over 4 plus I times root 2 plus root 6 over 4. And eventually, when you multiply all of these things, you're going to get something like 128 minus 128 root 3 plus I times 128 plus 128 root 3 as the answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.